In this video, I'm going to talk about sampling. So when we take a sample, this is a very, very important step when we're doing statistics. It is really important that it is random. So this first definition, a random sample is the process of using chance to select individuals for a sample from a population. And that's really important because if you try to leave it to yourself, if you believe that you can randomly select people, that's 100% not true. So if I were as a teacher and standing in front of my class and I'm like, I'm going to pick three students randomly from my head, the three students I pick are not going to be random. Maybe I picked them because they look like they weren't paying attention. Maybe I picked them because they do pay attention. Maybe I picked them because I thought they'd be the most interesting group of students to talk to for the sample. I mean, there could be a variety of reasons of why I chose those three students. And the problem is I've biased the sample. It is no longer representative of the population because my bias has caused there to be issues. So if I happen to pick the three students who weren't paying attention, I'm now biasing my sample in that way. Why were the students not paying attention? Do they have a lot on their mind? Are they really stressed out? Are they tired? Are they working a lot, right? Like there's a lot of reasons why those three students weren't paying attention. And now my sample contains all three of those people who aren't paying attention. And therefore they all have traits in common and they've biased the sample because not everybody in the class may have those traits in common. So you want to use chance to do a sample. It's going to make certain that you're not biasing it and therefore your results are valid. There are going to be four techniques we're going to kind of go through in this video. And the first one is a simple random sample. A lot of people, by the way, use SRS to represent that as like an acronym for shortcut. Okay, so if like you're reading something and it says SRS and they're referring to the sample, that means they did a simple random sample. So in order to do a simple random sample, we actually need to know everyone in the population. Okay, so we have to have a list of everyone in the population, and that's called a frame. So here, let me go ahead and define that. The list of all individuals within a population is called the frame. All right. Now, to do a simple random sample using chance, the definition's kind of funny. Let's go ahead and write it down and then we'll just kind of discuss it. A sample of size n. So using n to represent that size, whatever that magical size is. We use lowercase n to represent it, okay? From a population of size capital N. So capital N for the population, lowercase n for the sample, is a simple random sample. And here I'll use the abbreviation SRS. If every possible sample of size n, lowercase n, because I'm talking about the sample, has an equally likely chance of occurring. Has an equally likely chance of occurring. Squeezing it in. There we go. All right. So that's the definition. What it means is, one way of thinking of it is every person in the population has an equally likely chance of being chosen being the sample. But the way they've worded it is, if you're picking a sample of like 5 people, every 5-person combination has a chance of being chosen. Every single one has an equal chance of being chosen. They are all possible as the result. Okay, so as you see from this little picture here, they've chosen 5 people from this sample and they're random. There's no pattern to it. They're kind of spread out. Some of them are darker blue, some of them are teal, right? Like whatever that's supposed to represent. And the idea is that it's randomly chosen from the entire population. Now, there's a few ways to do this. We're just going to use a random number generator. As you could see, I went ahead and selected random.org, and here I preloaded that so we can actually use it for the example that we're about to do. But there are other ones out there. that do random generation of numbers. There are old school techniques of using pages of random numbers. Some people use their graphing calculators. Since we don't require a graphing calculator, that's why we're not going to use that technique. But here, we're going to use that website to do this next example. So if you want to kind of click on it and get it loaded, I went ahead and preloaded it just because it's a little bit slow sometimes. But first thing I'm going to do as I get going here, I'm going to number these. And since I'm working in Word, I'm going to go ahead and use my numbering list to make that a little quicker. Yay. All right. So now I'm going to go ahead and I'm going to go to this website and I'm going to generate a random sample of 5 out of these 20 students. Okay. So, what's random about this site is that everybody who does this, like if each of you went ahead and put in your parameters and generated it, you're going to get a different list than me. And that's not always the case with some of these websites. Some of them you get the exact same list if everybody's putting in the same information because it's like using a little formula to generate it. So that's why I like this website. First thing I'm going to do is the minimum number of people was 1. In other words, we have 1 to 20. We have, 1 to 20 people in this class that we're creating a list for. And I hit generate. And so the first number chosen is 6. So I'm just going to write this down. Go ahead and hit generate again, and it's going to generate a new number, 14. Now it's possible it could generate the same number twice. And if that happens, 11. Just re-click and do a different number. So go ahead and make sure you get 5 distinct numbers. So if you do this with me, you'll get a different set of numbers, and that's fine. Maybe we'll have some in common, but there you go. There's my random numbers. All right, so I wrote them down. And let me come back here, and I'm going to go ahead and write them down here as well. Oops, I just realized I accidentally bumped a number. That's fine. Okay, so the first one chosen was 6. And that was William Cunningham. So I'm going to write that person down. They are part of my sample. Number 14 is Raj Patel. Number 11 is Jorge Lopez. 19 is Alexandria Wood. And number 12, that was the last one, is Ken Lundquist. So there we go. There's my random sample of 5 students off this roster. And that's how you would do it. Okay, so there's a simple random sample. Now, stratified sample. A stratified sample kind of builds on a simple random sample, but this one is a little bit different. As you can kind of see by the picture, they've kind of separated people by some sort of characteristic, all right? And that's what makes a stratified sample different is that, let's say I'm looking at students and maybe I'm interested in seeing the difference between full-time and part-time students. And I want to make sure that both of those groups are included in my sample, okay? That would be an example of a stratified sample, ensuring that I have both full-time and part-time. So like for instance, up here, just to drive this point home, and then I'm gonna start writing all that down. You'll notice that 4 dark blue were chosen and 1 teal, right? So if this was representing part-time and full-time students, like maybe full-time are the dark blue and part-time is the teal, that means that I have an overwhelming number of full-time students as part of my sample. And even though it's random, maybe that's not very good when I'm trying to see the results, and maybe I'd like to do some sort of study or comparison of those groups. So to ensure that I have a good number of them, a more equal number, like this picture, we break them up and then we sample from each group individually. That's the definition of a stratified sample. So this sample is obtained by separating, the population into non-overlapping groups, which are given the name strata for this technique, and then obtaining a simple random sample I'll spell it out this time since I have space. A simple random sample from each of those groups. Or you could say from each stratum. Stratum is the singular version of strata. Okay, so let's talk about an example of how this would look. So a professor at OCCC wants to conduct a student survey. How could this be done using a stratified sample? So kind of depending on what you're talking about, you divide the student population up. Let's go off of what I just said. Let's do full-time and part-time students. So full-time students will be one group, and then part-time students would be the other group. Plural. Okay. And then what you would do is you would want to make certain that you grab enough full-time students and enough part-time students. So let's just say I want a total sample size of 50 students. Okay, 50 students. And let's say I know that full-time students make up, let's say 30% of the student population, leaving part-time to be 70. I have no idea, by the way. I'm just fully making those up. Okay. So that means that I want to make certain that the full-time students are a smaller representation than the part-time students. So maybe if I go ahead and take 30% of 50, that's going to give me 15. So maybe I'll sample 15 students full-time, and then the other 35 I'll sample from the part-time. And then I'll use my simple random sample generator to randomly grab numbers, and I'll have a list of all of the population, but I'll do a simple random sample to obtain this group and another simple random sample to obtain this group once I look at both of those groups separated. All right, that's how you'd kind of approach it. So I'm not going to go through that process because I don't have this list, but it's just kind of talking in general, the process of how to do that. All right, another type of sample, systematic sample, is obtained by selecting every like fifth person or 10th person or 27th person. I don't know, whatever that magic number is, you're like counting off to select people. So here, let me write that down in general. So a systematic sample is obtained by selecting every kth individual from the population. And typically the first individual you choose is usually a random number. So the first person chosen, you usually like get a random number generator and you like start at like, I don't know, let's say the random number generator gives you 6, is randomly selected. So you then say, okay, so I'm going to count off 6. And then the 6th person is when you start then counting every, I don't know, 10 or 12 or whatever your K is. And K is going to depend on the size of your population. So if you're looking at a really large group of people, K is going to be probably really big. But if you're looking at kind of a smaller group, it might be much smaller. But here's the advantage of this system. It doesn't need a frame. And I'm going to write that down because it's an important note. It doesn't need a frame. So in both the simple random sample and the stratified sample, you need a frame because you're doing a simple random sample and a stratified sample. So you need the list of all the people, but for this, you don't. You just need to have this number that you're going to count off every single time. So let's say I still want to pick a group of 50. Same little scenario. Still want to pick a group of 50. And I'm afraid I don't know how many people at our school. Let's just say there's 2,000, just nice even number. Okay. So if there's 2,000 people and I want a sample of 50, that means it might make sense to make K 40. So I'll count off every 40th person. And then the very first person I pick, I'm going to do a simple random sample to generate the first person I'm going to pick. All right. So let's say maybe I'll just toss a die and I got a 3. Okay, so I'm going to start with the third person I see, and then I'm going to count off 40 for every single student thereafter. Okay, if I'm looking at a population of size 2000. And what's nice about this is you could like just do this by hand on the campus without a list. I don't have to go obtain that, and I can just count off until I get my sample of size 50. All right, the next version, a cluster sample. This, as you can kind of see by the picture, is we kind of have like this grouping going on, right? They've kind of separated these people into 5 different groups. Then they've picked 2 of the groups and they're going to sample all of those people. Okay, so that's how a cluster sample works. So a cluster sample is obtained by selecting all individuals in a randomly selected, oops, selected is spelled with one L, randomly selected collection or group of individuals. So there's still kind of a grouping thing going on, like stratified, but the groups are smaller. And when you select your group, you're going to actually sample everybody in that group. That's how a cluster sample works. Now, as our example with this professor going around surveying people, a great example of a cluster would be to maybe group people into classes. So the groups are classes. And then I would, or I'm assuming, of course, that I'm the professor. The professor is going to randomly go ahead and select certain classes. So maybe I'd have a list of the classes, which is really easy to obtain. I can get that from the website. Okay, so I look at the list of the classes. I randomly select, oh, let's say 7. I randomly select 7 classes. I contact the teachers, and then I survey everyone in the class. So that'll probably get me really close to my n equals 50 number, depending on the classes that are chosen. Some classes are bigger than others. But that's kind of a different way of doing it. It's a lot more convenient. And it kind of makes sense too, based on my position at the school as a professor. Other professors are probably very willing to let me go and survey their students, which is super convenient because now their teacher's kind of giving their blessing. So they're all going to probably participate. But when I'm doing like a systematic sample, they may not participate because maybe they're busy and they're like, I'm sorry, I can't help you right now. Right? Maybe they don't want to participate, but by kind of trapping them within the class frame, I'm getting this opportunity to possibly get more data, and it may not take as long. It's a little bit more convenient. It's kind of an easy way of doing it in terms of the frame. It's easy to get the group of classes, and then I just have all those students within the class. Now, there is another sampling method called the convenient sample, and it's exactly as it sounds, it's supposed to be convenient. But what makes a convenient sample problematic, and you can kind of see it in the picture, is that you're sampling whatever is convenient, and therefore it is not random. So they kind of show the sampler, this gray individual, picking the 5 people closest. And they're like, cool, done, right? So that's not random. And that's the problem with a convenience sample. So a convenience sample does not use randomness. So this method does not use chance to select individuals. Or you could say that the individuals are not randomly selected. All right. So an example of this is maybe then as an instructor, one version of this is I like reach out to my own students. I survey my own students. Okay, students in professor's classes. That's a convenient sample. Another one would be like maybe they sit at a table and they ask people to participate. Right? They go to the common area and they sit at a table and they ask people to participate. So that's problematic because now we're just not looking at random samples. All the people who are in my classes have something in common. They're taking math classes, and maybe their majors, depending on the classes I'm teaching, might all coincide together. Maybe because of the time slots I teach, I tend to have more full-time students than part-time students because I teach in the middle of the day, and a lot of part-time students maybe can't teach in the middle of the day, right? Like there's certain scenarios that come out of a convenience sample that means I might be looking at a biased group because it was convenient. Same with the table. If you're sitting at a table and you're asking people to participate, who participates, right? People who are bored, people have the time on their hands. Maybe they're not part-time students for that reason because they're not rushing around to go to their job and then go home to their family. I don't know. It's this idea that we're biasing it because we're allowing people to self-select, and that's a problem. Okay, so we're going to label this as what type of sampling method used. So each of them we're going to read through, and then we're going to identify which sampling method was used to do it. So a sample of 100 undergraduate San Jose students is taken by organizing the students' name by classification: freshman, sophomore, junior, senior, and then selecting 25 from each. Okay, so they've organized them into groups. So that's either stratified or cluster. They're the ones who do grouping. But because they're doing a random sample of 25 from each group, and these are probably very large groups, that's a stratified sample. So they did like a simple random sample within each group. That's a stratified sample. A random number generator is used to select a student from the alphabet listing all in fall semester. Starting with that student, every 50th student is chosen until 75 students are included. Oh, I love this. Super obvious. Systematic samples, like the easiest to identify. Every 50th students, that's counting off. That's a systematic sample. A completely random method is used to select 75 students. Each undergraduate student in the fall has the same probability of being chosen. Okay, that's a simple random sample. So there was no grouping, no counting off, simple random sample. Okay, freshman, sophomore, junior years are numbered 1, 2, and 3, 4, respectively. Random number generators used to pick 2 of those years. All of the students are sampled. Okay, so that's a cluster. So they're doing the same grouping method they did in the first one, but now they're sampling everybody within that group. That's a cluster sample. Administrative assistant asks to stand in front of the library one Wednesday and asks the first 100 students he encounters what they paid for tuition. Okay, that's convenience. Standing out in front and just asking people to participate, that's a convenience sample. Okay, so in the next video, we'll talk about the errors in the sampling method. And that's it.